The purpose of this video is to show you the steps involved with calculating a Pearson correlation. And the example is based on the data associated with the years of education completed and annual earnings divided by 365, which is a per day earnings dependent variable. The first step involves calculating z-scores. So each of the x scores, years of education completed, need to be transformed into a z-score, which I call zx. And the same thing has to happen for the y-scores. They have to be converted into zy. So the first step involved with calculating a z-score is calculating the mean. Now I should say that I assume that you have some familiarity with what a z-score is and how to calculate one. This isn't a video about calculating z-scores per se. So the first step involves calculating the mean. And I'm going to do this in Excel. In fact, I'm doing the entirety of this calculation in Excel because doing it by hand on a piece of paper is an opportunity really to make a mistake. So here I've got a mean of 13.80. So people on average have 13.8 years of education completed. And to calculate the standard deviation quickly, use the STDEV function and then specify the rows that you want to include in this analysis, B2 to B41. So the standard deviation is 3.07. I'm going to do the same thing for Y because I'm going to have to do it later. And I might as well just do it now, as I'm in the routine of calculating these descriptive statistics. So the average earnings per day is 118.98, and I'm going to calculate the standard deviation. So D2 to D41, bam, got the standard deviation. Doing this by hand would take several minutes to calculate the standard deviation, even with just cases of 40. So this is the great efficiency associated with knowing the STDEV function in Excel. So now that I've got the mean, 13.80, and the standard deviation of 3.07, I can calculate the z-scores, and I can calculate them also with a function in Excel. It's called Standardize. And it's going to ask me for the x value that I want to standardize, which is B2, and it's going to ask me for the mean, which is 13.08, and the standard deviation, which I actually can't remember. I think it's, 3.05? Let me just put that down and then I can double check. So there we go, it's 13.80. I wasn't very far off the mark. 3.07 is the standard deviation. So let's fix this up. 13.80 and 3.07. And there's the z-score for ID1 or case 1. So a value of 17 corresponds to a z-score of 1.04. So somebody who's more than a standard deviation above the mean, just a little bit. Now to calculate the z-scores for every single case, I can actually double-click the corner of this cell, and it creates all the z-scores automatically. Now these two z-scores are meaningless right at the bottom, so I'm going to get rid of those. So case 40 has a z-score of 0.065, and case 1 is 1.04. So now I need to do the same thing for the y values. So I've got the mean of 118.98. It's actually 9. I'm only going to do it to 2 decimal places. You could do it to 3 or 4 to get greater accuracy. 0.19. So now with the mean and the standard deviation calculated, I can now calculate the z-scores for y. And I'm going to use the standardize function again. Equals standardize. And we have D2, and the mean is 118.99. And the standard deviation is 69.19. And there's the z-score for case 2. So 35.08, which is lower than the mean of 118, and therefore I got a negative z-score. So it's a bit surprising given that there's a positive correlation as I describe in the textbook, but the positive correlation is not so big that everyone's going to have corresponding positive and negative z-scores. So let's calculate the z-scores for the remaining cases. And here they are. And I'll get rid of these 2 pieces of information because that's redundant. So now I've got the z-scores for both the x variable and the y variable, and now I can multiply them together because I need the zx, zy variables, which is the product of the two z-scores. So equal C2 times E2. Whoops. So now I just need to do that for the entire list. You can drag it down or double click. Now the final step involved is summing all these product scores. It's not the final step, but nearly the final step. And here we have 13.12, which is very close to what was reported in the textbook. The textbook has 13.19. This, rounded to 2 decimal places, is 13.13. And the reason there's a difference is simply due to rounding. Excel's been calculating these at a very high level of decimal places, whereas in the textbook table, I actually did the calculations only to 2 decimal places. But 13.13 is very close to 13.19. Now the last thing I need to do is I need to divide this by n minus 1. And that is the foundational element of the Pearson R formula, is the sum of zx and zy divided by n minus 1. So this last step is me dividing that sum. So F42 divided by 39. That's the sample size. And I get a correlation of 0.3365, which to a rounded perspective is 0.337, which is very close to the 0.338 reported in the textbook. So the usefulness of doing this video is 2 things. One is showing you the calculations involved with the Pearson correlation. And secondly, showing you how to do it in an Excel file so that you don't make mistakes if you're given an assignment, for example, to do something by hand and you have to show all the calculations by hand. I would do it in an Excel sheet and then transcribe the results afterwards. If you have to do it to 2 decimal places, then you can change these values very easily to something like that. So I think this is a very useful way to learn and teach how to calculate a Pearson correlation in a way that's more sophisticated than just doing it with a piece of paper and a calculator.